Hello and welcome back. Today we'll be again looking at lesson two within Unit One. This is going to be the second part to two variable equations. And today specifically, we're going to be looking at can we graph one of our equations? Can we graph an equation in two variables? So pulling from yesterday, our last video, we constructed this equation to represent the cost for renting an inner tube. So we had this equation y equals 5 plus 2x. Y was the cost of the inner tube. 2 was the 5 was that fixed value. 2 was that price per hour to get this equation. Now, it's personal preference, but personally and more commonly, you're going to see that same equation written as such. You're going to have that variable first. It's not to say that first equation is wrong. Just that second equation is just a little bit more of a common notation. How are things going to be written? So the goal again today is can we get that equation graphed? Well, one of the first ways we always talk about graphing is ordered pair. Can we just plot some points? And so we're going to start by finding a couple pairs of ordered pair that we then can plot on a graph, connect the dots, and draw our line. So if I would say plug in the value 0 for x, 0 times 2 is 0, plus 5 is 5. It's going to be an ordered point that we can then plot. I'm going to go ahead and make a few more ordered points. At any point, I'm taking that value 2, plugging it in for the x, and I'm solving for what that value of y is. You may notice that for these ordered pair, these look very similar to the values that we had in the table of values on the prior video. And in fact, they are. So if you would actually scroll up on your notes to problem number 1, you would see those were the same actual points. But still the question is, can we graph them? So all I'm going to do is I'm going to take these points, I have 6 of them here, and I'm going to put them on a graph. And that's what I've done here. I've gone and graphed those 6 points. Now, do note, on my graph specifically, my horizontal axis, they go on increments of half, 1, half, 2. Those horizontal ticks aren't full, so just do be a little careful on how you plot your points. But we have a graph for the number of hours that you keep it and the cost of renting a tube. And there is something to be said for that when x is 0, what that value actually is. I mean, if you keep the tube for 0 hours, do you have to pay anything? But that's a different day, a different question to be tackled. But still, we've gotten our points graphed. We've plotted those points. We've connected them with a straight line. So the question comes into, is that linear? And I spoiled the answer for us. Is that a linear equation? And the correct answer is yes, that is linear. But why is it linear? That's the better one. Why? Do you know why it is linear? Well, to tell if this equation or a line is linear, what we're looking for is that constant change. So to go from that first point to the next point, how much did you go up and over? That up and over, that up and over. How much did you go up? So in this case, we went up from 7 to 9, we went up 2. How much did we go over? We went over from 1 to 2, went over 1. Yes, it's 2 little tick marks, but that unit measure went over was just 1. Now if we follow that, we're always going up 2, over 1. Up 2, over 1. There's that consistency there. There's that constant change. So the question here is, explain why it's linear. Yes, it's linear. And the reason is it's a constant change. Constant change. And that's going to come back to play here in just a minute. What that constant change is. Maybe you're already thinking of the right word there. We'll be coming to that. Question 11, real quick. It's sort of a conceptual. It's asking, why is our graph of our renting a tube and its cost, why are we only restricted to the first quadrant? If you normally think you have a graph that has quadrant 1, 2, 3, 4, why are we restricted to only quadrant 1? Well, if you think about it, if we go to one of those other quadrants, we start turning into negative numbers. And, well, there's really not such a thing as negative time. or negative cost. I mean, you can't keep an inner tube for -3 hours. You can't pay -$4. So why are we? Why is a graph only in the first quadrant? We're gonna say we can't have negative time. Can't have negative time or money. Time or money. So that's sort of why we're limiting ourselves to the first quadrant. Question 13, again, these are sort of conceptual. What is the y-intercept of the graph? Describe the y-intercept in this representation. So again, going to this graph, well, which one's the y-axis? Well, they got them labeled for us. This is the x. That's the y. So the y is our up and down, the x is the left and right. So what is our y-intercept? Our y-intercept is where we intercept that axis. And that was that first point we had. The y-intercept was 5. So what is the y-intercept? It's that point 0, 5 is our y-intercept. So describe the y-intercept as it represents the situation. This one's kind of funky per se, but it's the cost, what do you say? It's the value when x is 0. Now, I realize for this situation, it's a little funky. There's a $5 cost with a 0-hour rental fee, but we'll move past that. But that's just sort of looking at the y-intercept, where that intersects. 13 says, what is the slope of the graph? Describe the slope as it represents in this situation. Now, slope is something we hadn't talked about, but it's sort of based on number 10. It's that constant change. How do things go up? Maybe you remember back from Algebra 1 or geometry, slope was that rise over run, how things change. So in our graph, what was the rise? What was that rise? What was that run? What was that rise? What was that run? That rise and run, the change in the y, the change in the x, that rise and run is exactly our slope. So if we go down here, what is the slope of the equation? Well, the rise was 2 over the run. It's the rise, the run. In this case, it's going to be 2. Now, if we do a little bit of connecting the dots as we wrap up this video, our original equation was as such. Our original equation was y equals 2x plus 5. Do we see that y-intercept anywhere on the equation? And we do. Right there. That is our y. Let's make that in pink. That is our y-intercept. Do we see that slope too anywhere? We do. We see that slope right there in front of that x. That is the slope. And in fact, you will always see that. Your slope will, in a linear equation, our slope will always be connected to that variable. That whatever number is in front of the variable is our slope, and whatever is added or subtracted on the end is always going to be our y-intercept. Now, if we wanted to use those values, we could then use those to graph a little bit easier. It tells us where to start. We could start at that 5, and then we could do the rise over run, rinse and repeat. I hope this video helped you on how to graph an equation starting from points, and we build into what the slope and intercepts were. I look forward to working with you again. Take care, be safe, and have a great day.